Numerical problems. Starting from a stationary position, Shravan paddles his bicycle to attain a velocity of 3 meters per second in 60 seconds. Then, he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 4 seconds. Calculate the acceleration of the bicycle in both the cases. A car travels from rest with a constant acceleration a for t seconds. What is the average speed of the car for its journey if the car moves along a straight road? A particle moving with constant acceleration of 3 meters per second squared due west has an initial velocity of 9 meters per second due east. Find the distance covered in the 5th second of its motion. Click the tab to view the solution. Let us know the graphical representation of motion. Generally, newspapers and magazines use different types of graphs to present the information in an interesting way. They often use bar graph, pie charts and line graphs which provide greater details of the information and make the information more interesting. To describe the motion of an object, we can use line graphs. In this case, line graphs show dependence of one physical quantity such as distance or velocity or another quantity such as time. Now, we will discuss about the distance-time graph. To draw the distance-time graph for the given data, take a sheet of graph paper and draw 2 lines perpendicular to each other on it. Now mark the horizontal line as XOX'. It is known as the x-axis. Similarly, mark the vertical line YOY'. It is called the y-axis. The point of intersection of XOX' and YOY' is known as origin O. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we take the time along the x-axis and the distance along the y-axis. Now choose a scale to represent the distance and another to represent the time on the graph. For the motion of the car, the scale could be x-axis 1 centimeter equal to 1 second and y-axis 1 centimeter equal to 5 meters. Mark values for the time and the distance on the respective axis according to the scale we have chosen. From the table, the set of values for time and distance are 0, 0, 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30, and 7, 35. The first number of the set represents time and the second number represents the corresponding distance. To mark the set of values 0, 0, look at 0 on the x-axis and 0 on the y-axis. This point is the origin. To mark a point for the set of values 1, 5, look for 1 on the x-axis and draw a line parallel to y-axis passing through this point. Look for 5 on the y-axis and draw a line parallel to x-axis passing through this point. The point of intersection gives the point that represents 1, 5. In the same way, mark the points corresponding to the different sets of values as shown in the image. Join all the points on the graph. It is a straight line which is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed, that is uniform motion. However, if the speed of the object keeps changing, the graph can be of any shape, that is non-uniform motion. So, we can say that the distance time graph indicates the type of motion, whether it is uniform motion or non-uniform motion. Hence, we can conclude that the distance time graph gives information about the distance covered by an object in a definite time interval, and also the distance covered by an object at any instant of time. Now let us know the procedure to calculate the speed using distance time graph. The distance time graph can also be used to find the speed of an object at any instant of time. To find the speed of an object, consider a small part AB of the distance time graph shown on the screen. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now on the graph, AC denotes the time interval T2 minus T1, while BC corresponds to the distance S2 minus S1. From the graph, it can be observed that in time interval T2 minus T1, the object traveled a distance equal to S2 minus S1. Then, the average speed of the car is S2 minus S1 by T2 minus T1. Speed gives the idea of how fast the body moves. In general, bodies move in a particular direction at an instant of interest, and this direction may not be constant throughout the journey. Here we will know about the velocity time graph. The change in the velocity of an object with time can be represented on the velocity time graph. In this graph, velocity is taken on the y-axis and time is taken on the x-axis. Case 1. For an object moving with uniform velocity, the graph will be a straight line parallel to the x-axis. This is because the velocity does not change with time. The distance traveled by the object between the points A and B with velocity 20 km per hour is determined by the following steps. We know that velocity is the ratio between speed and time. So, speed equals to velocity into time. Here, V equal to 20 km per hour equal to AC or BD. T equals to T2 minus T1. Therefore, S equals to AC into T2 minus T1, which equals to AC into CD. S is equals to area of the rectangle ABCD. Case 2. For an object whose velocity is increasing with time, the graph is a straight line having an increasing slope. This is because the velocity increases by equal amounts with equal intervals of time. The area under the velocity time graph is the distance, that is magnitude of displacement of the object. The distance traveled by an object between the points A and E is the area ABCDE under the velocity time graph. It implies S equals to area of ABCDE. Implies to S equals to area of ABCDE. This is S equal to area of rectangle ABCD plus area of triangle ADE. Implies to S equals to AB into BC plus half into AD into DE. Case 3. For an object whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. This is because the velocity decreases by equal amounts in equal intervals of time. Case 4. For an object whose velocity is non-uniform, the graph shows different variations. This is because the velocity changes by unequal amounts in equal intervals of time. Now, let us see the equations of motions by graphical method. The motion of a body moving with uniform acceleration can be described with the help of three equations called equations of motion. The equations of motion are v is equals to u plus at, s is equal to ut plus half at square, v square minus u square is equals to 2as. Click each tab to know more. Equation for velocity-time relation. V is equals to u plus at. Consider a velocity-time graph for a body moving with uniform acceleration a. The initial velocity of the body is u at a and it reaches a final velocity v at b in time t. Draw the perpendicular lines BC and BE from point B to the time and velocity axis, so that the initial velocity is OA, final velocity is BC, and time interval is OC. Now draw a line AD parallel to OC. We observe that BC equals to BD plus DC, which equals to BD plus OA. Substituting BC equals to V and OA equals to U. Then we get V equals to BD plus U. Implies to BD equals to V minus U. Acceleration equals to change in velocity by time. A equals to BD by AD, that equals to BD by OC, which equals to V minus U by T. Implies to AT equal to V minus U. Implies to V equal to U plus AT. Equation for position-time relation. S is equals to ut plus half at square. Consider a velocity-time graph for a body moving with uniform acceleration a, traveling a distance s in time t. The distance traveled by the object between the points A and B is the area OABC, which is a trapezium. That implies to S equal to area of OABC. Implies to S equal to area of rectangle OADC plus area of triangle ABD. That implies to S equal to OA into OC plus half into AD into BD. Substituting OA equals to U, OC equals to AD equals to T, and BD equals to V minus U, which equals to AT. Therefore, we get S equals to U into T plus half into T into AT. That implies to S is equal to UT plus half AT square. Equation for position-velocity relation. V square minus U square equal to 2as. Consider a velocity-time graph for a body moving with uniform acceleration a, traveling a distance s in time t. The distance traveled by the object between the points A and B is the area OABC, which is a trapezium. That implies to S equal to area of trapezium OABC. S equals to OA plus BC into OC by 2. Substituting OA equal to U, BC equal to V, and OC equal to T. We get S equals to U plus V into T by 2. From velocity-time relation, T equals to V minus U by A. Therefore, S equals to U plus V into V minus U by 2A, which equals to V square minus U square is equals to 2as. Follow-up work. Suggest few examples for motion of an object where its speed remains constant but velocity changes. What is the displacement of the body if it returns to same point where it is started? Give one example in daily life. You have successfully completed the chapter Motion.